All right, grade nines. Let's hop straight into it here. We just finished up unit 4.1 last lesson, so we're going to move on to 4.2, which is discussing like terms and unlike terms. A few things I want to touch on before we get started on the actual notes themselves. If you have yet to submit anything since we have finished classes, I need you to try to do that ASAP. I'm going to be sending emails home for those of you that I haven't heard from yet. Those are mainly OLAs I need you to be handing in because that's going to affect your mark because we can't do the in-class assessments like we did. I posted an updated version of your marks. If you're not happy with where it's at, it's most likely not because you've been failing the stuff that you've been handing in, but more so probably because you're not actually handing anything in. So let's try to get the stuff handed in. That way we can get ourselves to a passing grade. If you need some extra help, send me an email. If you're feeling overwhelmed, send me an email. All right. I need you to communicate with me. That way I can help you out. Anyways, let's move on. We're going to discuss like terms and unlike terms today. And we're going to use the same method we used in the last lesson. We're going to use algebra tiles. So, like terms and unlike terms. I need to find my page here that I need to get to. There we go. So let's take a look at an example set of tiles. I'm going to copy this example that I like out of the textbook here, and we'll go through it together. So here's a collection of red and yellow algebra tiles. Let's say we've got one square here. Remember, yellow is positive, okay, and red is negative. All right, so red is negative, yellow is positive. So we've got a positive x squared there. Let's give a few small little negative numbers here. Let's go with 3, and then a big red square, 2 red x's. Let's get a couple of yellows in there. And then let's do this. And a couple more of these. Now, what you'll notice about these is we're familiar with all those shapes if we followed the notes from last lesson. If you didn't, you have to go back and catch up on those because we're going to continue on with that. Now, it'll make our lives easier if we can group the tiles that are similar to one another. So we're going to group all of the big squares together. So that's what our next step is, group all of the similar tiles. So there's our 2 yellows. Let's do our red. Good, maybe I'll just grab this and I'll do little check marks beside the ones that I've moved down. Let's move onwards to our reds. We've got 4 red X's, X tiles. They're the skinny ones like this. And then, so that's good. And let's do the small little guys here. Let's do the 2 positives on the top, and we'll do the 3. So those are good. And then we need to do the 3 negatives underneath. All right. So there we go. There you have it. They're all grouped together now. If I close this, we'll be able to see the colors a little bit better. I've got my windows open. Can you see that better? Or is that too dark now? I think that's all right, eh? There we go. That looks good. All right. So how can we simplify this now? So what's the point? What am I getting at here? Well, we've got like terms. Similar shape means that they're like terms. They're terms that are similar. And what we can do is when we look at them, we can actually do a cancellation, which will really help us. I notice that I've got a positive. Remember, red means negative and yellow means positive. So if I have a positive and a negative beside one another, those are going to cancel, right? Those are going to end up just being equal to 0. So right there, those two can cancel one another out. I see 2 positives and 2 negatives here that can also cancel each other out. So these are like terms that are opposite. We call them 0 pairs. They're pairs that when we add them up, they equal 0. Okay, so that's why we call them that. So what that ends up giving us is, if I was to look at what these tiles actually represented here based on our last lesson, we would have had positive 2x squared, because we had two positive x squared tiles, minus 1x squared for the red one. And then remember, red means minus, so minus 4x plus 2 for the yellows, and then minus 3. So what ends up happening, if I cancel this out and cancel these out, I end up with just 1 square, 4 of the skinny lines, and 1 negative number, negative 1. Right? So what we can see is 2x squared minus x squared gives us 1x squared minus 4x squared. And then plus 2 minus 3 gives us just minus 1. So what this ends up equaling is x squared minus 4x minus 1. So what this basically told us is that 2x squared minus x squared minus 4x plus 2 minus 3 simplifies to x squared minus 4x minus 1. We just saw it visually. Okay, so that's what we learned there. Let's move on to the next example, the next page. So what were we working with there? We were working with things called like terms and unlike terms. What's the definition of a like term? There's a couple things that a like term needs to have. It needs to have the same size and shape if we represent it with algebra tiles. If we're not using algebra tiles and we're actually using symbols, then the terms have to have the same variable, and they have to have that variable raised to the same exponent as well. Remember, the x squareds were like terms, okay? Like terms, not the x's of the x squareds. So you have to have the same variable and have that variable raised to the same exponent. Do some examples here. Something like negative x squared and 3x squared. Those are like terms, okay, because they both have that x squared. Or another example, you could have 15r cubed and negative 3r cubed. Those are like terms because they have the same variable and they have the same variable and the same exponent. Same variable, same exponent. Unlike terms, when we're doing algebra tiles, we'll have different sizes, different shapes. And then if we're doing with symbols, they can have the same variable, but they, as long as they're raised to different exponents, then they will be unlike terms. They can also have the same raised exponent, but if they're different variables, they're also unlike terms. So a couple examples here, you could have 4x and negative 3y. Those are unlike because the variables aren't the same. Or you could actually have them both be x's. You could have, say, 8x squared and negative 2x. Those are also unlike terms because the exponent is different. So here the variable is different, and here the exponent is different. Okay? So that's the difference between like terms and unlike terms. Now it's really easy when we're using algebra tiles to be able to see like terms and unlike terms because we're basically just looking for the same shape, right? Same size and same shape. But when we are not using algebra tiles, when we're using symbols, we have to look at the variables. So let's do another example here. Using algebra tiles, let's simplify the following polynomial. So use algebra tiles to simplify the polynomial 4n squared minus 1 minus 3n minus 3 plus 5 minus 2n squared. Okay, so seems like a lot, but if we use algebra tiles, this will make our life a lot easier. I'm going to use algebra tiles, but I'm going to draw them smaller than I did in the last example because we have lots of algebra tiles. So 4n squared, that's a positive n squared. So that means that I'm going to have, these are my big squares now. Okay, I know they look a lot smaller, but it's just I'm trying to save myself some room. So there's my 4n squared. Maybe I'll write it underneath. 4n squared. Minus 1. Okay, how do I do minus 1? Minus 1 is going to be just one little guy like that. So that's minus 1. And then what's our next one? Minus 3n. So I need to do 3. Let's do it like this. 1, 2, 3. So minus 3n. Minus 3 again. So let's do 3 of the little tiles. 1, 2, and 3. So that's minus 3. What are we at now? Plus 5n. So I need to have 5 of these skinny ones here. 1, 2, 3, 4, 5. So that's plus 5n. And then minus 2n squared. So that's 2 of the bigger ones. 1 and 2. That would be minus 2n squared. Okay, so there we go. That is our algebra tile representation for that polynomial. Now it says to use algebra tiles to simplify it, but it also says to record the process symbolically. So I've done that. I have my algebra tiles and I have my symbols. So what my next step is going to be to group like tiles. So I'm going to say next step, let's group them. This should only take us 3 steps. So I'm going to group like, let's group like, I'm going to say tiles, but I'm also going to go slash terms for when we're using symbols. And that'll kind of just follow. So we start out the same way, but I'm just going to group all of my big ones together. So 1, 2, 3, 4. But I'm going to bring over my similar tiles right here, 1 and 2. Okay, I'm going to write out what I have here again, 4n squared minus 2n squared. So we can kind of maybe see what's going on here now. Now let's group together our positive and negative terms. So 1, 2, and let's go with 3 down here. And the reason I'm doing this, I'm just trying to kind of chunk a few of them together. So that's my negative 3n, and then plus 5n was 1, 2, 3, 4, 5, all nicely grouped together, plus 5n. And then we'll group together all of our little negatives here. We had negative 1 and then negative 3. I'm going to put them all right there. So that is negative 1, negative 3 gives us negative 4. And you know what? I'm doing one extra step here I don't want to do. Let's keep them separate. Let's take it one step at a time. Negative 1, negative 3. Those are technically separate. All right, so now we've grouped them. Now our next step, so that was our grouping like terms. Now our next step is remove, does anybody remember what we call them? They're called zero pairs. So remove the 0 pairs. I'm going to circle my 0 pairs right now. So where are my 0 pairs? There's one right here. These 2 are going to cancel out with those 2, right? So that's going to be 0. And then these 3 are going to cancel out with these 3. Right there, that's also going to be 0. So I removed my 0 pairs. And when I do that, now all I'm left with is I just draw what I have left. It's really not a difficult step. I have 2 of those left. I have 2 of these left. And I have 4 of these left. Drew them a little bit bigger that time, but that's okay. That's all I have left. So then all you have to do is write out the terms that you have left. 2n squared plus 2n, right? This is two, these are the n squareds, there's two of them. Positive for these, so plus 2n, and then minus, because red is minus, minus 4. So our final answer ends up looking like 2n squared plus 2n minus 4. So what we end up seeing happening here is these like terms subtracted from one another, and same with these two right here. And then those ones got combined. So that is our kind of visualization of what is occurring when we're using algebra tiles to simplify polynomials. Now, we can't always be drawing out algebra tiles every time we want to simplify polynomials. So we're going to take a look at how to do it without using algebra tiles. The thing that's nice about the algebra tiles is it gives us a really nice introduction to what we actually are going to do when we're not using algebra tiles. So all we have to do now is do the exact same steps. Remember, our first step was to group the like tiles. Well, in this case, we're not going to use tiles. We're just going to use terms. So group the like terms and then add the coefficients, right? That's what we did on the last page. I guess I'll show you one more time here, right? We added the coefficients. 4 minus 2 gave us 2. Minus 3 plus 5 gave us plus 2. Minus 1 minus 3 gave us minus 4. Now we could see it visually, but that's actually what was happening mathematically as well. So let's group the like terms first, because they're all kind of all over the place here. 14x squared minus 11 plus 30x plus 3 plus 15x minus 25x. So what this is going to be is 14x squared minus 25x squared. I'm grouping the x squareds. And then let's group just the x's. So let's do the x's first. I always like to go in order of descending exponent values. So x squared first, then plus 30 plus 15x. And then our ones that don't have x's attached to them, negative 11 plus 3. So if we were looking at this in terms of like terms, there are x squareds, there are the x's, and there are the numerical values with no x, right? The x to the zeros technically. So all you have to do now, last step, is just evaluate the coefficients. So our first step is to group. And then our second step is going to be to add slash subtract coefficients. Big word, coefficients. Okay? Let's add slash subtract coefficients. So 14 minus 25. Mental math, 14 minus 25 is going to give you negative 11x squared. 30 plus 15 plus 45x. And then negative 11 plus 3. That's tough. Negative 8. So there you go. There's your answer. Maybe circle it. Put a square around it. Stay in that habit. Negative 11x squared plus 45x minus 8. Got one more example here. Simplifying polynomials with two variables. This seems like it's going to be a lot trickier, but it's really the exact same steps. Grouping like terms and then combining them. So grouping them, combining the like terms, and what I mean by that is adding or subtracting the coefficients. So let's do the exact same thing. I'm going to try to go in order of descending exponent values, and I'll go in alphabetical order as well. So x comes before y, so we're going to start with x's and y's, x's then y's when they're raised to an exponent of 2, and then the xy combinations if they're raised to the exponent 2, and then we'll move down the exponents. So I'm going to start with this one right here, negative 3x squared. And then we'll move to the y's, so minus y squared, minus 3y squared. So remember, those are not like terms because even though they're all raised to the 2, sorry, the x's and the y's are not like. These ones are. but the x's and the y's are not, because even though they're both raised to the exponent 2, they have different variables. Now we'll move on to the ones that are not raised to an exponent. So we'll go with x first, and then we'll go with the xy combo. So negative x, and then these two, which we've got plus 4xy and plus 2xy. So there we go. I've grouped them all, and I've put them in an order I like to do that. Now, you don't necessarily need to put them in the same order that I did. If you want to just combine them first and then put them into an order, that's totally fine. I like doing it this way, just because it's what I'm used to. So there we go. You've got your y squareds, which are similar terms, and then you've got your xy's, which are like terms. So you're going to combine those by adding the coefficients. So the negative 3x squared doesn't combine with anything, so it stays the same. And then negative y squared minus 3y squared could give you, that's minus 1 minus 3, so minus 4y squared. And then minus x. And then plus 4xy plus 2xy should give us plus 6xy plus 6xy. So that's it. That's your value. That's all I've got for you for today to do. I'm just going to put a square around this. I'm trying to decide if I want you to put them in a specific order. I'm okay with that. I like that. I've seen sometimes you put the xy's at the front. That if you want to do that, that's totally fine. For right now, we'll leave it at that. So there is some homework. I'll also post this on the Google Classroom if you don't want to have to pause and copy that down. That's what I want you to do from the textbook for the next couple days. So page 222, numbers 4, 6, 8, 12 ACE, 13 ACE, and 14 AB. If you're having difficulties with any of those, just shoot me an email and I can help you out. Besides that, we'll see you in the next video.